Okay, so today in class we introduced the topic of slope, and we're going to do some things with slope here for the next couple days, but today was just an introductory day. So again, our definition that we came up with, all right, is how steep a line, how steep is a line as it goes from left to right. All right, that's kind of the abbreviated definition of what we did in class today. So when we're trying to define or explain what slope is all about, we're trying to talk about how steep a line is. So if we look at our four examples that we have here, as we go from left to right, if we look at line C, we'll start with line C. As we travel from left to right, line C is going up. As we move across, line C is going up. So we would say that line C has a positive slope. If we would look at line D, as we move from left to right on our line, we are going to drop down. So we would say that line D has a negative slope. A and B are a little more trickier. If we look at line B, well actually line B, as we travel from left to right, line B does absolutely nothing. Okay, it does not rise. It does not drop. So we would say that line B has a slope equal to 0. All right, and then line A, as we travel from left to right on our grid, we don't even see line A until 1 second, and then it disappears the next. So the slope for line A is undefined, because as we travel, how steep is it? Well, it doesn't change, and we only see it for 1 point as we travel from left to right. We don't even see it anywhere, and then it appears, so it's kind of like and then nothing. So the slope for vertical lines is undefined, slope for horizontal lines is 0, and then our slope for our diagonal lines can be positive or negative depending upon whether they are rising or falling. Okay, now we discussed that in class today. The other thing we like to do here is if it is a positive or a negative value, we want to attach a value with that. All right, we want to attach a value to that, and we normally give that in the form of a fraction. Okay, and definition, how do we come up with that fraction, is rise over run. Rise over run is our formula for calculating slope. How do we calculate the rise? We simply need to subtract 2 y's. Okay, y2 minus y1. How do we calculate our run? Remember, when we run, that is a horizontal movement, so that's where we want to calculate in. We use 2 x's. Anytime we want to calculate a change or a difference, all we need to do is subtract. So now we have a formula for calculating slope. So if we're given any 2 points, let's say our line travels through the points 8, 6, and 3, negative 1. If we were asked to calculate the slope for that particular line, now all we have to do is get our values plugged into our formula. So 8 is an x and 3 is an x. Okay, so x, 8 minus 3. We can make this our second one. We can make this so we can plug those in, 8 minus 3. We just have to be consistent now. All right, so if we're going to make this our x2, because we put it in first, then we need to make sure that stays as y2 minus our y1. So again, be consistent, x2, y2, x1, y1. 8 minus 3 is 5. That becomes plus. So this line has a slope, a positive slope of 7/5. So now we know that it is, since it's positive, we know this line would be going up, and it's going to rise 7 for every 5 that it goes to the right. And again, remember, universal letter for slope is m. M. Okay, so we might be asked to calculate the slope just given 2 points. In fact, they could just give us an equation and want to know, what is the slope of this line? We don't have a visual. We don't have anything to look at other than this plain equation. So what we have to recognize then is, okay, our formula says we need 2x's and 2y's if we want to calculate the slope. So guess what? We need to come up with 2x's and 2y's, and this is where we can use our little t-chart that we've been using since day one to come up with those values. 0 is always a good place to start. So if we guess a 0 here, 2/3 times 0 is 0 minus 6. So that gives us a -6. Remember, when we have fractions in our equations, the denominator is our clue. And since it's a 3, our next guess should probably be a 3 of some kind. So we could use 3, 6, 9, whatever you're more comfortable with. So we can substitute in our 6. 2/3 of 6 is 4 minus 6. So y equals -2. Again, we can stop here. We are not being asked to graph, so it's not necessary for us to come up with 3. This problem wants us to determine our slope. So now we have our 2 points that we required, so we can use our formula. Trick here is putting the right numbers in the right place. So y2, and again, based on what we come up with, we're not going to be able to dodge the negatives. So y2 minus the first one. So -2 minus -6. And then on the bottom we have to be consistent. x2 minus x1. So we got 6. This becomes plus. So -2 plus 6 is 4. And that reduces to 2/3. So that equation we started with has a slope of 2/3. There is no graphing tonight, so no graphs are necessary. All it is practicing calculating your slope. Tomorrow we will get that phased into our graphing. Bring any questions you have to class tomorrow. Have a good night.